lesson is about the inverse of the exponential function. These examples are not on your notes. If I give you an exponential function like 2 to the power of x, and I tell you to draw the graph, and you read further in your question and you see that you also need to draw the inverse. It's always a good practice to use a table to get fx, and then when you have the table, you can just swap the x and y values to get the inverse. Now I've already calculated the y values, so just copy the table down. Now, in order to work out the inverse, we already know that we have to swap the x and the y values from fx. Fx is also y. Y equals 2 to the power of x. So to get the inverse, we say x equals 2 to the power of y. And now you use the definition of log to calculate y. Y is the exponent, so y stands alone. That equals to the log of x base 2. And there's your inverse function. So, the logarithmic function, this one, is the inverse of the exponential one. Those two are inverse functions of each other. And around which line do you get an inverse and a normal function? Yes, around y equals x. So this is our reflection line. Now if you draw them, only draw the graphs, and then you just point, let's say, 2 coordinates which you swap, so that you can see that the inverse actually swaps the x and the y's. I use the table to plot my f coordinates, then I drew the line, and then I use the table again, but I swap the x and the y's to draw the inverse function. I'm going to carry on with example 2. I will come back to this one. Example 2. Now I give you a base, which is a fraction. So let's just rewrite that fraction as a base 2. So it will be 2 to the power of negative 1 to the power of x. And that equals to 2 to the power of negative x. And I use that function to draw my table. And to get the inverse, I just swapped the x and the y's. Ask again. We're just going to finish this graph and then we do exam questions. So you can paste them so long. If, however, I ask you to calculate the inverse function, we know that we have to swap the x and the y's. So x will be equal to 2 to the power of negative y. And that will be equal to 2 to the power of negative 1 to the power of y. Which gives you x equals a half to the power of y. Or you can do it with the logarithms. Minus y equals the log of x base 2. But I want a positive y, so I divide both sides with minus 1. Y will be minus 1 times the log of x base 2. Then y will be equal to, this stands in front of the log, so I put it as an exponent, log of x to the power of minus 1 base 2. Therefore, y will be the log of 1 over x base 2. In order to draw these functions, I used these as coordinates and I drew my f. Then I swapped the coordinates and I drew the inverse function.